We know that any quadratic equation can be written in the form ax squared plus bx plus c equals 0. We can find the roots or the zeros of a quadratic equation by using the quadratic formula. So our roots could be x1 and x2 respectively. The terms under the square root in the quadratic formula are known as delta or the discriminant. So delta equals b squared minus 4ac, and we can rewrite the quadratic formula in terms of delta. It will be negative b plus or minus the square root of delta all over 2a. We say that delta is a discriminant because it discriminates between the types of roots. In other words, the value of delta tells us what type of roots a particular quadratic equation has. When it comes to the nature or the types of roots of a quadratic equation, there are 4 cases. The first case is when delta is less than 0 or negative. For example, when delta is equal to negative 10. In this case, x, the roots of the equation, will be given by negative b plus or minus the square root of a negative number all over 2a. We know that the square root of a negative number is non-real. So in this case, the roots will be non-real. In other words, they won't exist. When we draw a graph of the quadratic equation, which is a parabola, we see that in this case, the graph doesn't touch or intersect the x-axis. The second case is when delta is equal to 0. In this case, we'll have a 0 under the square root in the quadratic formula. So essentially, we only have one root, which is negative b over 2a. When we draw a graph of this quadratic equation, it will touch the x-axis at one point only. In this case, the roots are real, equal, and rational. The third case is when delta is greater than 0 and a perfect square. For example, when delta is equal to 4, which is both a number greater than 0 as well as a perfect square. In this case, we'll have a perfect square under the square root in the quadratic formula. When we draw a graph of this quadratic equation, it will intersect the x-axis at 2 points. Here the roots are real, unequal, and rational. Then the fourth and last case is when delta is greater than 0 but not a perfect square. For example, when delta is equal to 10, which is a number greater than 0 but not a perfect square. So in this case, we'll have a non-perfect square under the square root in the quadratic formula. When we draw a graph of the quadratic equation, it will also intersect the x-axis at 2 points. Here the roots are real, unequal, and irrational. Please try the following exercise before you look at the answers. Let's look at your answers to this exercise. We are given the value of delta, and we have to say what the nature of the roots are. So in A, delta is 7. 7 is not a negative number, so we know that the roots will be real. So whenever delta is not negative, the roots will be real. Then secondly, 7 is not equal to 0, or 7 isn't 0, so we also know that the roots will be unequal. Then thirdly, 7 is not a perfect square, so we know that the roots will also be irrational. So in B, delta is equal to 0. Once again, 0 is not negative, so we know that the roots are real. Of course, delta is equal to 0 means that the roots will be equal as well. And then lastly, 0 is also a perfect square. So we know that the roots will be rational. So real, equal, and rational. In C, delta is equal to 16, which is not negative. So we know that the roots are real. Then it's not 0, so we know that the roots are unequal. And 16, of course, is a perfect square, so we know that the roots are rational. Please try this exercise before you look at the answers. So let's look at your answers to exercise 2. Here we are given the nature of the roots and we have to state the value of delta. So in A, we are told that the roots are real, equal, and rational. The roots being real tells us that delta must either be greater than or equal to 0. However, the roots are also equal and rational, so that tells us that delta must be equal to 0. Then in B, the roots are real and unequal. Once again, we know that if the roots are real, delta must be greater than or equal to 0. Because the roots are unequal though, we know that delta must be strictly greater than 0. You should note that in this case, we are not told whether the roots are rational or irrational, so we don't know whether delta is going to be a perfect square or not. Then in C, the roots are real and irrational. Once again, because the roots are real, we know delta must be either greater than or equal to 0. And we are also told that the roots are irrational. Now, we know that delta must be greater than 0 in this case, because if it's equal to 0, then the roots will also be rational, since 0 is a perfect square. So delta is greater than 0 and not a perfect square. So in the rest of this lesson, and in the next few, we want to look at the following types of problems that you'll encounter for nature of roots. Firstly, determining the nature of roots. Secondly, finding the value of a constant. Thirdly, proving the nature of the roots. And lastly, application problems. So example 1a here deals with determining the nature of the roots when the coefficients in the quadratic equation are numerical. And it says discuss the nature of the roots of each of the following quadratic equations. And we are given these 8 equations. So let's have a look at the first one. We have x squared minus 3x minus 5 equals 0. Now, this equation is already in standard quadratic form. In other words, it's already in the form ax squared plus bx plus c equals 0. So we can start straight away by writing down the values of a, b, and c. So a is the x squared coefficient, and it's 1. So a is 1. B is the x coefficient, and that's negative 3. And c is the constant, which is negative 5. We can write down the equation for delta. We know that delta equals b squared minus 4ac. And we substitute in these values. So it's negative 3 squared
minus 4 times A times C. So we get 9 plus 20, and this of course is 29. So from this we can see that delta is greater than 0, but not a perfect square. So not a perfect square. And hence the roots are real. They're real. They are irrational. And since delta is not equal to 0, they are also unequal. Let's look at B. So we have x minus 3 all squared equals 4. Now, the equation here is not in standard quadratic form. It's not in this form. So we first have to write it in standard quadratic form. And we can start by squaring out the left-hand side. Now, just remember that a minus b all squared is a squared minus twice ab plus b squared. So applying this expansion to the left-hand side, it's a first term squared, then this sign, then x times 3 times 2, which is 6x, and then plus 3 squared, which is 9. Now we can bring the 4 to the left-hand side. 9 minus 4 is 5, and this equals 0. Now the equation is in standard quadratic form, in other words in this form, and we can write down the values of a, b, and c. So a is 1, b is negative 6, and c of course is 5. We can find delta. We know that delta equals b squared minus 4ac. We can substitute in these values. So it's going to be negative 6 squared minus 4 times 1 times 5. This is 36 minus 20. And this of course is 16. 16 is a perfect square. So we can see that delta is greater than 0 and a perfect square. So therefore the roots are, they're firstly real since delta is greater than 0. They are going to be rational since delta is a perfect square. And once again, since delta isn't equal to 0, the roots will be unequal as well. Let's look at C. So we have x into x minus 1 equals 3 into x minus 1 less 1. Once again, this equation is not in standard quadratic form. So we're going to multiply into the brackets on both sides. So we're going to get x squared minus x equals 3x minus 3 less 1. We can add the like terms on the right-hand side. So it's 3x minus 4. Now we can bring all the terms to the left-hand side. So negative x minus 3x is negative 4x. And bringing the negative 4 to the left-hand side as well, it becomes positive 4. This equation is now in standard quadratic form, and we can write down the values of a, b, and c. A, of course, is the x squared coefficient, which is 1. Then b is negative 4. That's the x coefficient. And c is the constant, which is 4. Now we can substitute into delta, or into the equation for delta. So it's going to be negative 4 squared minus 4 times 1 times 4. This is 16 minus 16, which is 0. So delta turns out to be 0. And now we can write down the nature of the roots. So then the roots are, firstly, they are real, since delta isn't negative or less than 0. So they're real. They are also equal, because delta is equal to 0. And they are rational, since 0 is also a perfect square. So then the roots are real, equal, and rational. Let's look at the fourth equation here. So we have 3x squared equals 2 into x plus 1 less 5. We can start by multiplying the 2 into the brackets on the right hand side. We can add like terms on the right hand side. And now we can bring everything to the left hand side. Now the equation is in standard quadratic form, and we can write down the values of a, b, and c. A, of course, is the x squared coefficient, which is 3. B is the x coefficient, which is negative 2. And c is the constant, which is 3. We can now substitute into the equation for delta. So we're going to get negative 2 squared minus 4 times 3 times 3. And this is 4 minus 36, which of course is negative 32. So we see that delta is a negative number. In other words, delta is less than 0. And therefore we can conclude that the roots are non-real. So because delta is a negative number or less than 0, the roots do not exist as real numbers. So they are non-real. Then coming to E, we have a fraction here in this equation. It's x plus 2 over x equals 3. And we want to write this equation in standard quadratic form. So we can first get rid of the fraction by multiplying through by the LCD. In this case, of course, the LCD is x. So x times x is x squared. 2 over x times x, the x's cancel, and we're left with 2. And on the right hand side, we have 3 times x, which is 3x. We can bring all the terms to the left hand side. And this, of course, is in standard quadratic form. So we can write down a, b, and c. A is the x squared coefficient, which is 1. B is negative 3. And c, of course, is 2. Now we can substitute into delta. So we get negative 3 squared minus 4 times 1 times 2. And this, of course, is 9 minus 8, which is 1. Now, 1 is a perfect square, so we can see that delta, therefore, is a perfect square. And hence we can conclude that the roots are, firstly, they are real since delta is greater than 0. It's not less than 0 or negative. So we know the roots are real. It's a perfect square, so we also know that the roots are rational. And of course, delta isn't equal to 0, so the roots are unequal. So the roots are real, rational, and unequal. So let's look at f. We have 3 over x less 1 over x minus 1 equals 2. We're going to get rid of the fractions by multiplying through by the LCD, which in this case, of course, is x into x minus 1. So multiplying the first term here by the LCD, x into the LCD, x minus 1 remains, times the numerator. Then multiplying the second term by the LCD, x minus 1 into the LCD, x remains, times the numerator. So 1 times x, of course, is x. And then we multiply 2 on the right-hand side also by the LCD. So we get 2 times x into x minus 1. We can multiply into the brackets on both sides. So it's going to be 3x minus 3. And on the right-hand side here, it's going to be 2x squared minus 2x. We can first add like terms on the left-hand side. So 3x minus x is 2x. Now we can bring all the terms to the left-hand side. So we're going to get negative 2x squared. Then 2x plus 2x will give us 4x. And we have less 3 equals 0. This is now in standard quadratic form. And we can write down the values of a, b, and c. So a is negative 2. B is 4. And c is negative 3. Now we can plug into the equation for delta. So it's going to be 4 squared minus 4 times negative 2 times negative 3. This is 16, and in minus, that's going to be 4 times 2, which is 8, times 3, which is 24. So 16 minus 24. This, of course, is negative 8. So we see that delta is a negative number or less than 0. And we can conclude that the roots are non-real. Let's look at the second last equation. So here we have z squared equals 3, and we must find the nature of the roots of this equation. Now note that we don't have an x in this equation, we have a z instead. That doesn't make any difference though, it just means that z is the independent variable in the equation. Then secondly, we want to take the 3 or bring the 3 to the left-hand side. And this equation will then be in standard quadratic form. Now recall that standard quadratic form is ax squared plus bx plus c equals 0. We can easily see that this equation is in standard quadratic form when we rewrite it as follows. We can rewrite it as z squared plus 0z minus 3 equals 0. So from this we can see that b, the z coefficient, is in fact 0. So let's write down the nature of the roots by first writing down the values of a, b, and c. So a is 1, the z squared coefficient. B we said was 0. And c is negative 3. Now we can plug into the equation for delta. So we're going to get 0 squared minus 4 times 1 times negative 3. And this is in fact equal to 12. So we see that delta is equal to 12. Now, of course, 12 is a number greater than 0, and it's not a perfect square. So we can see that delta is greater than 0, but not a perfect square. so not a perfect square. And now we can write down the nature of the roots. So the roots are, firstly, they are real, since delta isn't less than 0 or negative. They are also unequal. So unequal, since delta isn't equal to 0. And the roots are also irrational, since delta isn't a perfect square. So irrational. Let's look at the last equation. So we have the square root of 2 times p squared minus the square root of 3 times p minus the square root of 2 equals 0. Once again, we don't have an x in this equation, we have p's. But as we said, all that means is that p is the independent variable. Then secondly, we also have surds in this equation. But we can deal with that by using the laws of surds. This equation, of course, is in standard quadratic form, so we can straight away write down the values of a, b, and c. So a is the p squared coefficient, which is square root 2. B is the p coefficient, which is negative square root 3. And c, of course, is the constant, which is negative square root 2. We can plug these values into delta. So it's going to be b squared, which is negative square root 3 all squared, minus 4a, so 4 times square root 2, so 4ac, so negative square root 2 in here. Now, remember this rule of surds. The square root of a squared is just equal to a. So a negative squared is a positive, and the square root of 3 squared is just 3. Then a minus times a minus is a plus. So plus 4 times, and then we know that the square root of a times the square root of a is a. This is using the laws of surds. So the square root of 2 times the square root of 2 is just 2. This, of course, is 11. So we can see that delta is greater than 0 or greater than 0, but not a perfect square. So greater than 0 and not a perfect square. Now we can write down the nature of the roots. So the roots are, firstly, they're real, since delta is greater than 0, 11 being greater than 0. So the roots are real. Also, they will be unequal because delta isn't equal to 0. So unequal. And delta is also not a perfect square, so the roots will be irrational. So then the roots are real, unequal, and irrational. So let's look at your answers to this question. In A, we have 3x squared minus 2x plus 4 equals 0. Now, this equation is already in standard quadratic form, so we can write down the values of A, B, and C. A is the x squared coefficient, which is 3. B is the x coefficient, negative 2. And C, of course, is the constant, which is 4. Now we can find the value of delta. and we simply substitute these values in the into the equation for delta. And on a calculator, this comes to negative 44. So we can see that delta is less than 0. And we can conclude that the roots are non-real. Then coming to b, we have 6 minus y squared equals 0. We're going to start by rewriting the order of the terms. So we have it in the form ay squared plus by plus c equals 0. So it's minus y squared minus y plus 6 equals 0. This is now in standard quadratic form, and we can write down the values of a, b, and c. So a is the y squared coefficient, which is negative 1. B is the y coefficient, which is also negative 1. And c is the constant, which is 6. Now we can find delta. So substituting these values into the equation of delta. And on a calculator, this comes to 25. So we can see that delta is greater than 0 and a perfect square. So we can conclude that the roots are, firstly, they are real since delta is greater than 0. So they're real. Then delta is a perfect square, so they're also rational. And delta isn't equal to 0, so they are also unequal. Then in C, we have x squared equals 2 into x minus 1 plus 1. The equation is not in standard quadratic form, so we need to write it as such, and we can start by multiplying out on the right-hand side. So 2x minus 2 plus 1, and this is 2x minus 1, and we can bring everything to the left-hand side. So x squared minus 2x plus 1 equals 0. Now we can write down the values of a, b, and c. So a is 1, b is negative 2, and c, of course, is 1. So then finding delta, it's going to be negative 2 squared minus 4 times 1 times 1. And this, of course, is 4 minus 4, which is 0. So delta is 0. And we can conclude that the roots are, they're going to be real because delta isn't less than 0. So real. They are going to be equal because delta is equal to 0. And they're also going to be rational since 0 is also a perfect square. So real, equal, and rational. Then in D, the equation is obviously not in standard quadratic form. And we also have fractions to deal with. So we're first going to get rid of the fractions by multiplying through by the LCD. So we're going to multiply through by 2x into x plus 1. So then 2x into the LCD, x plus 1 remains, times the numerator. So 1 times x plus 1. Then x plus 1 into the LCD, 2x remains, times the numerator, which is x. And then we also multiply the right-hand side by the LCD. So we get 6x into x plus 1. We can multiply out on the right-hand side. Now we can bring all our terms to the left-hand side. So we have negative 2x squared minus 6x squared is minus 8x squared. Then x minus 6x is minus 5x. And we still have a plus 1. And this is 0. So this equation is in standard quadratic form. And we can write down the values of a, b, and c. A is negative 8. B is negative 5. And c, of course, is 1. So now we can find delta. So it's going to be negative 5 squared minus 4 times negative 8 times 1. So this is 25 plus 32, which is 57. So we can see that delta, firstly, is greater than 0, and it's also not a perfect square. So delta is greater than 0 and not a perfect square. So we can conclude then that the roots are, firstly, the roots are real since delta is greater than 0. 57 is greater than 0. They are unequal since delta isn't equal to 0. And because delta is not a perfect square, 57 is not a perfect square, they are also irrational. So real, unequal, and irrational. Let's look at E. So here we have p squared minus 2 equals 0. I'm going to rewrite this equation in order to illustrate that this is a quadratic equation in standard form. So it will be p squared minus 0p minus 2 equals 0. So now we can write down the values of a, b, and c. A is the p squared coefficient, which is 1. B is the p coefficient, which is negative 0, which of course is the same as 0. And c is the constant, which is negative 2. So now we can find delta. So b squared will be 0 squared. A is 1. And c is negative 2. So this comes to positive 8. So we can see that delta is greater than 0, but not a perfect square. So we can conclude that the roots are, firstly, real, because 8 is greater than 0, delta is greater than 0. So real. 8 is not a perfect square, so it's going to be irrational. And since delta is not equal to 0, the roots are also unequal. So unequal. So the roots are real, irrational, and unequal. Then coming to F, we can first multiply through by 3 to get rid of the fraction on the left-hand side. Now we can square out the left-hand side. We can bring all the terms to the left-hand side and add like terms. So negative 4m minus 3m is negative 7m, and 4 minus 6 is negative 2. The equation is now in standard quadratic form, and we can write down the values of a, b, and c. A is 1, the m squared coefficient, b is negative 7, and c, of course, is negative 2. Now we can find delta. So we can substitute in our values. So it's negative 7 squared minus 4 times 1 times negative 2. And we can do this on a calculator, and it comes to 57. So we can see that delta is greater than 0, but not a perfect square. So not a perfect square. So we can conclude that the roots are firstly real, since delta is greater than 0. It's unequal because delta isn't equal to 0. And it's also irrational. So irrational, since delta is not a perfect square. Let's look at G. Once again, we can multiply through by the square root of 3 to get rid of the fraction over here. So it's z squared minus, now the square root of a times the square root of a, of course, is a. This is using the laws of surds. So the square root of 3 times the square root of 3 is just 3. Then we're also going to use this law of surds, that the square root of a times the square root of b equals the square root of a times b. So then the square root of 12 times the square root of 3 equals the square root of 3 times 12, in other words, the square root of 36, using this law. And of course, this simplifies to z squared minus 3z minus 6. Now we can write down the values of a, b, and c. So a is 1, b is negative 3, and c is negative 6. So then finding delta, we can substitute in. And this is 9 plus 24, which is 33. So in this case, delta is greater than 0, but not a perfect square. And so the roots will be, so the roots are real, since delta is greater than 0, unequal, since delta isn't equal to 0, and irrational. So irrational, since delta is not a perfect square. Then coming to the last question here, so coming to H, we can multiply out the left-hand side. So we get x squared minus x equals 0. Now we can write down the values of a, b, and c. A is the x squared coefficient, which is 1. B is the x coefficient, and it's negative 1. And we can see that there's no constant here. So c equals 0. Now we can find delta. It's going to be b squared, so negative 1 squared, minus 4 times 1 times c. And c, of course, is 0. So we end up with delta equal to positive 1. So we can see that delta is greater than 0. So greater than 0, and also a perfect square. So a perfect square. And we can write down the nature of the roots. So the roots are, firstly, real, since delta is greater than 0. It's unequal. So the roots are unequal because delta isn't equal to 0. And because delta is a perfect square, the roots are also rational. So the roots are real, unequal, and rational.